Just an introduction to our presentation. This presentation will focus on sources of AC generation in the three provinces of British Columbia, Yukon, and Alberta. The population of British Columbia as of late 2015 is 4,631,302. Yukon has a small population of 37,343, and Alberta of 4,196,457.
AC power generation in the Yukon territories. The main generating stations are hydroelectric. Most power is generated from water dams, which are located in the Whitehorse Rapids, Aishihik, and Mayo. These are the three main sources of AC power generation in the Yukon territories. All three sources produce a sum of 75 megawatts of power capacity in the Yukon territories. The other main power generation comes from wind. The largest wind generation station is located in Hackle Hill, having a capacity of 0.81 megawatts of power. Using basic math, we can calculate the significance of the wind farm in the Yukon territories. The Hackle Hill wind farm produces 1.07% of the total power capacity out of all major AC generation sources in the Yukon territories.
AC power generation in British Columbia. British Columbia has a lot of ways of generating power, but their main way of generating power is using hydroelectric dams. BC has over 30 hydroelectric dams, which generates over 86% of the province's electricity. Three of the major dams located in BC are on the two great rivers of BC, and those three dams are called the Mika, the Revelstoke, and the WAC Bennett. With all those dams combined together, British Columbia generates almost 11,000 megawatts of power, which is a decent amount, because the whole province only generates around 12,000, so that leaves only 1,000 for other stations. But speaking of other stations, the second most common way of generating power is diesel generators. The operation of a diesel generator is fairly basic. It pretty much just uses a prime mover for generation, and it spins an alternator which generates current, and I'll go on that more in this slide. How does a diesel generator work? A diesel generator is a generator that acts like an alternator. A diesel motor moves the prime mover, which then moves the alternator, which produces power. If it's a working alternator, of course, but if you can see this diagram in the bottom right corner, you can clearly see the 9 main parts on the diesel generator itself. Those include an engine, of course, an alternator, fuel system, which is diesel, the voltage regulator, the cooling and exhaust systems, the lubrication systems, the battery charger, the control panel, and lastly the main frame that holds it all together. The components of it are fairly basic on the fuel system and the exhaust systems and the lubrication systems, just to keep the machine running, but a big role in producing actual power would be the voltage regulator, because it's the component that regulates the voltage leaving the machine. It converts the incoming AC voltage to DC current, which then is rectified to AC current, and it just keeps repeating that cycle until there's enough power to operate at its full capacity.
AC power generation, Alberta. The primary origin of electricity generation in Alberta comes from natural gas, but used to be coal during 2014. In 2014, Alberta produced over 44,000 gigawatt hours from coal, which made up for 55% of electricity generated. Alberta is promoting more efficient energy and plans to add over 10,000 megawatts of thermal and other renewable energies. The installed generation capacity as of now for Alberta is 16,242 megawatts. Alberta has a total of 7,080 megawatts generation capacity for natural gas, followed by 6,258 megawatts generation capacity for coal. Wind power generation is rising in Alberta. Wind currently has 1,459 megawatts of generation capacity installed in Alberta. Within the last 2 years, Alberta has seen wind additions of about 350 megawatts of installed capacity, located in Black Spring and Old Man River.
How a hydroelectric dam works. A hydroelectric dam uses water to turn a turbine which produces mechanical power. Since this mechanical power is being converted to electrical power, the turbine may be considered a generator. Fast-moving currents of water flow through the penstock when the reservoir intake allows it to. The penstock delivers water to the turbine, in which produces mechanical power. The mechanical power is sent through a powerhouse, which converts it to electrical powers. In this case, generators are used to convert mechanical power to electrical power. The supply voltage coming through the power lines to the distribution center are stepped up by a transformer and are ready to be delivered to customers around the province.